Hello, I'm Greg Elkenbart with Mirantis. I'm here with Abhijit Prabhun from Netronome, and we're going to talk to you about how to turbocharge your VNFs. So first, a brief introduction to Mirantis. Mirantis provides one of the leading open source cloud platforms using OpenStack, Kubernetes, OpenContrail, and Ceph to deliver clouds. We can help operate your clouds with up to 4 nines SLA and then transfer it to your internal IT team. As part of our OpenContrail development, we have integrated with Netronome, and I'm here to present the performance results to you. We focused during this development on the VM-to-VM performance because that's necessary for distributed large-scale VNFs that we typically support for our telco customers. As you can see here, we're using the vRouter path, which provides a maximum VM compatibility, and the vRouter relay from Netronome is fixed to consume only 2 cores. Each VM is provided with 4 vCPUs and 4 gigs of RAM, and we're using a simple packet gen for this test tool. So as you can see by our performance, we were able to achieve close to 20 million packets per second. This is full duplex. So in and out counts as only a single packet. 15 at 10 gig, 20 million packets per second at 40 gig. While at the same time we've tested the base vRouter DPDK at 2 cores at only 4 million packets per second. So using the Netronome accelerator, we're able to achieve roughly 3 to 5x performance improvement in throughput. Latency is not shown here, but latency is also have been significantly lowered. So Abhijit?
Thanks, Greg. So I'll add one more point to what the performance results that Greg mentioned. So if you look at the 10 gig numbers, we're actually maxing out the line rate of the 10 gig at that 2 cores. And that's why we are also able to get much higher when you switch to the 40 gig line, 40 gig card. So short introduction on Netronome. We've been delivering network accelerators for high growth markets for about 15 years now. We focus on 3 market segments: NFV infrastructure, cloud IaaS, networking, and security and analytics. We have pioneered network flow processing as the mechanism to deliver that and have established a leadership in SmartNICs. We serve top-tier OEMs, public, private, and telco cloud service providers. In order to deliver this, what we do is we offer acceleration for COT servers. There's 2 aspects to our product portfolio. The hardware product portfolio consists of 2x10, 2x25, and 2x40 gig cards. This is, and you saw the performance numbers for vRouter that Greg showed for 2x10 and 2x40. On the software portfolio side, we offer OVS acceleration, vRouter acceleration, and CoreNIC, which is basically makes it a traditional NIC. By doing this, we are relieving the performance bottleneck that happens on the host when you're deploying any kind of VM or VNF. It takes the cycles back that you would give to the NFV infrastructure and gives them back to the VM, so you can run more VMs, generate more revenue. It also brings the speed of software innovation to hardware, in this sense that we can do any kind of programming. These cards are highly programmable. We have OpenStack managed, Open vSwitch, Contrail, and CoreNIC. Specifically with Mirantis, we've been partnering for over a year and a half now, and we've done Mirantis OpenStack integration with OVS, Mirantis Cloud Platform integration with OpenContrail, and Mirantis OpenStack integration with standard Linux networking. In all cases, we can get up to 10x CPU core savings, 5x I/O throughput that you already saw with vRouter, 100% VM and VNF onboarding and mobilities because we support both VRT-IO and SR-IOV. Essentially, you can deliver an OpenStack managed homogeneous server infrastructure and get 3 to 6x better TCO. I'll show a little bit about our performance on the OVS as well. So this is how we do our OVS offload. The OVS from the host gets transparently offloaded onto the VNIC, onto the SmartNIC, and you can get 20x to 50x efficiency depending on what you're doing the performance measurement against. With that, I'd like to invite you guys to visit us at booth A26 at Netronome or booth C1 for Mirantis. And if you have time for questions, feel free to. Any questions? All right.
So there's SR-IOV, there's vRouter, and then there's this other thing, DFIO, or what is it?
Yeah, so the question is SR-IOV, vRouter, and what is XVIO? Yeah, so XVIO is essentially, we are providing the vRouter interface up to the VM, and we are providing performance like SR-IOV. So that's the vRouter relay that Greg showed. So we have a small relay that sits in between the VM and the SmartNIC and does the offload for that.
Getting the same 20 million packets?
So the performance numbers that Greg showed were with vRouter relay, absolutely, or with XVIO, yeah.
We did not test the performance with the SR-IOV path. We expect it to be another 5 to 7 million packets per second higher.
Yeah.
With SR-IOV?
With SR-IOV, yeah.
Let me add to that question a little more details. Is that like a user space widget sitting at the hypervisor layer, or I should say sitting at the host OS layer, or is it more of a kernel module?
So the question is it a host module or is it a user space or kernel module?
Third option.
Yeah. Yeah, so the XVIO is a DPDK app. So it sits in a host and it presents the vRouter interface up to the VM, and then it does a transparent offload onto the SmartNIC.
Gotcha, that would explain the reserve cores.
Yeah.
Okay,
And it needs an extra core. How many cores?
You can start with one core. The performance results that presented for vRouter were for 2 cores.
And one queue or multi-queue?
We can do both, one queue or multi-queue.
We were using multi-queue for the test, simply because DPDK packet gen can't really achieve 20 million packets with a single queue.
But don't you need a core per queue?
So yes, there were 4 vCPUs given to the VM for that reason, correct.
Oh, I see. You said 2 cores, meant 2 physical.
So he got 2 cores for his relay, and each VM had 4 cores for its packet gen.
Go ahead. Go ahead.
I was just wondering, did you exercise virtual function daemon from DPDK whenever you're doing some testing?
Virtual function daemon, not familiar with that. Maybe you can stop by offline. I'll get the answer from my engineering team in the mind.
So when you do these tests, is it like a single flow, or is it like a real-world application where you have multiple, thousands, tens of thousands of packets?
We're trying to simulate lots of packet flows through the DPDK packet gen application. Obviously, it does not really simulate the complexity of a real-world application because all packets are 64 bytes. But other than that, there is lots and lots of flows.
So what would you expect to happen?
So this is unoptimized performance. We try to achieve the performance results without trying to do anything weird. We could have gotten higher performance results if, let's say, we would have constrained the VMs to run on the same NUMA node as the NIC. We would have expected yet another 30% performance bump, but that's unrealistic, right? So you don't want to do that. So this is unoptimized performance, so you are expected to really achieve 20 million packets. As opposed to twisting yourself into a pretzel to do so.
Yeah, I'll add to that. I mean, you brought a very good point. There's a lot of different ways to benchmark. And we do benchmark in different ways. I mean, this is just one of the benchmarks that we showed here. We benchmark all the way from 1,000 flows, 10,000 flows, 250,000 flows, so on and so forth for the solution. So absolutely, if you are more interested in that, then maybe
so we'll hang around, folks. Unfortunately, we got the timing signal from sincerest apologies. So we'll hang around here in the corner for a little bit, answering additional questions. And please visit us at the booth.
Thanks.